Hello. So, in many of the classes, we did not have time to properly go through this proof. So, I just wanted to sit here and take the time to do it right. So, let's take a look. We need to prove that angle XZY is congruent to VZW. Okay. So we know that this is going to be at the end because that is the overarching statement we need to prove. So let's go ahead and write that. Do I know how many lines down? No. You never quite know how many steps there will be in a proof. So let's just put it down here. Angle X, Z, Y is congruent to angle VZW. Now, so let me just draw. So what we're trying to prove is that this angle, VZW, is congruent to angle XZY. Now, I don't want to put those and keep them there because then it gives me the idea that I've already proven them congruent, but I haven't. But that's what we're going for. So let's just erase that. We know what we're going for. So sit back and think. Usually, you start with a given. They tell you that two lines are parallel, that two lines are congruent, and you would start in putting them in this given, but they don't give us anything. They just give us this picture. They don't have any markings in it. So we do know, however, that this is a line, and these two angles must be 180 degrees because of that, and that these two angles must be 180 degrees. So let's draw that in. So we've got these two angles must equal 180, and these two angles must equal 180. And there's a place in the middle where they overlap, right? This angle, VZY, is the same in both this group of angles, this linear pair, and this linear pair. Linear pairs. Let's use that. The nice thing about choosing both of these linear pairs is that the angles we're trying to prove congruent exist in both of them. In order to prove that two angles are congruent, they have to be involved in the proof. So let's write that down. Let's find the blue angles first. So angle XZY is plus, we're going to do m, little m, meaning measure of angle XZY plus the measure of angle, what is that? YZV equals 180. So we add both those angles together, they're equal to 180 because they are a linear pair. Linear pair definition. Now, we're going to do the same thing for these angles in red. So let's write, we've got our step 2, the measure of angle WZV. Now, I could name it WZV, but if we're doing this in IXL, they're going to have us match this. So let's use VZW, measure of angle VZW. So that's kind of weird. Mathematically, I could use either letter, but IXL-wise, you kind of need to match what they say, I found. So measure of angle VZW plus the measure of angle, what do we use? YZV? YZV equals 180. Y, linear pair definition. Now, if you notice, both of these angles add up to 180 degrees. Therefore, we can put these two angles equal to each other. So I'm going to show you that the step 3, the measure of angle XZY plus the measure of angle YZV equals these angles, the measure of angle VZW plus the measure angle YZV. Why is that true? This is the transitive property at work. If A, or these two angles, are equal to 180, so these two angles are equal to 180, and these two angles are equal to 180, then they have to be equal to each other. Okay, what are we going to do with this? Let's take a look at the equation. And you'll notice that they both have angle YZV. YZV. Look, they both have angle YZV in common. So what happens if we kind of delete that from both sides? What is going to happen? So let's delete that here. We can do that by subtracting the measure of angle YZV minus measure of angle YZV from both sides. And that cancels out. What you're left with is that the measure of angle XZY is congruent to the measure of angle VZW. Now, how did we get from this step to this step? We just balanced the equation. We used algebra. Now, let's take a look at our picture. Look, we deleted that angle from both that linear pair. And we started with 180 degrees, and we deleted the same amount from both. So let's pretend it's 180 degrees. Let's just say this angle was 75 degrees. Then, because they both started with 180, and because we subtracted the same amount, both angles will be congruent. The really great thing about this proof is that it doesn't use numbers. Instead, it used the variable angle YZV. So by doing it that way, we've proved that for any angle measure, that this would be these two angles across from one another, also known as vertical angles, will be congruent. We have one last little step though. So let's see what we did. We know that the measure of each angle is the same, but it asks us to show that they're congruent. So in order to do that, one little step. So the measures are the same. Well, the definition, I'm just going to say def of congruence. They are congruent because the definition of congruence says Two angles that are of equal measure are congruent. Well, we proved they were of equal measure. Now we can just say they're congruent because that's the definition of congruence, two angles that are equal measure. So we did it. That is how we do the vertical angle proof.